So it's going to learn about projectile. And projectile would be like throwing something. You could either throw it straight in the air, like throw it up. You could just drop it, or you could slam something to the floor at whatever rate you want. And depending on what, like if you're on Earth or Pluto or what planet you're on, is how fast it falls. Okay, so if you're on a different planet, they have a different, what we call, force of gravity. Does that make sense? So, a projectile, you may have heard of like projectile vomiting. It's like shoots out, right? It's too early for that. Never mind. So a projectile is an object that is thrown, shot, or dropped. Usually shot straight up or straight down. Like if I took this marker and dropped it out the window, it would be straight down. And it would fall faster if I put a little force in it, right? Now these problems use a function of object's height, which the force of gravity and the force of gravity on Earth is 32 feet per second. That's the force of gravity. Different planets have different forces of gravity. The initial velocity, that's like, are you throwing it down, are you just dropping it, are you throwing it up? And we're just going to call that V. And I mean, you don't have a constant number for that. It just depends. Like if I'm a baseball player and I'm throwing a baseball, some people throw at a higher velocity than other baseball players. So that one's going to depend. But V is positive. Actually, I'm going to spell that out. Positive if you throw it up. And then if you just drop it, it'll be 0. And if you throw it down, it'll be negative. I don't know what kind of W that is, but there we go. Still doesn't look like a W. There we go. Alright, so all of this together makes the equation, which for any object on any planet, the formula is height equals 1/2 times gravity times time squared plus velocity times time plus h. And we didn't talk about h. H is your initial height. Like if I were to drop this pen from the top of my head, then my h would be 6'8". Does that make sense? So using that, how high you drop something changes. Your velocity changes. T is your variable. And we want to find out, like, how far is the pen in 1 second, 2 seconds, 3 seconds. And T is in seconds. But gravity, just assume, unless they tell us otherwise, that all of these are on the planet Earth. So 1/2, I forgot something, negative 1/2. So negative 1/2 times G half of 32 is 16. So my formula will be height on Earth half of 32 would be 16, and it'll be times time squared. And we don't know velocity, and we don't know the initial height. Questions so far? So on your test Thursday, you're going to be changing this number, and it depends on the planet. So it's not always 16. Okay. And most problems use meters anyway, not feet. There's a whole different formula for meters. I think it's 9.8 meters per second. Does that sound right? I think. I don't remember. All right, the famous hamster has come back. Mr. Parker must not like hamsters. So it's launched directly upward. At 64 feet per second. Well, that would be my velocity. And because I'm shooting it upward, it's positive. So V is 64. And I could make this problem harder by doing like inches per second. You have to convert to feet per second. But I'm not going to do that to you. And the platform is 80 feet high. So that would be my little h. That's how high you start. And they should say on Earth. That's good to know, but they don't. So write the function for the height of this object at any given time. Well, the height would equal negative 16 times time squared plus my velocity is 64. All I did was plug in for velocity. Plus my initial height. My initial height is 80. So what that means, and I'll show you, I'm going to type in X. You can't really type in T's. What's going on with this hamster? Need to change my window to about 100 because it was started out at like 80 feet above, right? Let's go a little higher. Uh, 200. Why not? So what's going on with this hamster? You're starting off at 80 feet, and you're launching him upwards. So he's going up in the air. Maybe he's 90 feet, 100 feet. He's going to reach a maximum height. And then what goes up must come down. And then it starts falling. And when it hits the X is when the hamster splats, right? So starts here, gets shot up in the air, comes down, hits the ground. Does that make sense? So I could look at a table. So at 0 seconds, if I plugged 0 in here, I'd get 80 feet in the air. That makes sense. That's when you start. When you started, the hamster was 80 feet up. After 1 second, if you plug 1 in here, he's 128 feet in the air. And then if you plug 2 in, he's 144 feet in the air. And then he drops back down to 128. Well, I don't know if you remember this from ICA, but 140 looks to be the vertex. That's the maximum height. He reaches a maximum of 144 feet. And then he comes back down, and after 5 seconds, he hits the ground. Does that make sense? So when will the object reach its maximum height? Now, you could tell that by the table because it repeats itself, 128, 128, 80, 80. We could tell it's after 2 seconds. But I'll show you the formula. The formula is, and that's the vertex formula, it's negative b divided by 2a. And this will tell you the when, like how long, the time, negative b over 2a. Well, a is negative 16, b is 64, and c is 8. So if you plug in this formula, it'd be negative b, negative 64, divided by 2 times a, negative 16, which makes negative 64 over negative 32, which equals 2. And we could have, I told you that from the table, remember? After 2 seconds. So, the hamster reaches its maximum height after 2 seconds. In other words, from 0 to 2 seconds, the hamster's going up. 2 seconds, that's where like, and then you start falling again. Does that make sense? It's kind of like the top of a roller coaster, where you reach the very top and you're just sitting at the top, and then boom, you come down. Okay, so that's where they're at, the very top. You've seen the cartoons where someone's like launched in the air and they just kind of, oh no, then they fall. Now, what will the maximum height be? We already found from our table. It's when x is 2, well, you plug 2 in to get 144. In other words, we know it's after 2 seconds. We have a function, so let's plug 2 and it'll spit out 144. So my height equals negative 16, and we're trying to figure out after 2 seconds what the height will be. So I plug 2 in for t, and I get height equals 144. So the maximum height will be 144. feet. I don't know if you remember this, but this is the vertex from ICA, where this is the x value, and this is the y value. You remember that? And basically, it's the top. And I didn't teach you this formula in ICA, but I did teach you how to do second calc max. Like this is a max. And then you choose to the left, you choose to the right, hit enter. You could find it that way too. I'm not going to show that way. Or you could use a table, if you know how to set up a table correctly. Questions? All right, next one. A freshman is thrown straight up in the air with an initial velocity of 29 feet per second. So he's being thrown up, so V is 29. And it's a shorter teacher throwing him up in the air. Well, I guess he didn't say teacher, but I guess. And he's showing him, he's 6 foot tall, so that's my age, right? So we have our velocity, we have our height, assume it's still Earth. So because it's still Earth, it's still negative 16. Because it's 32 feet per second divided by 2. So write the function for the height. Well, the height, and you could just use capital E to write out height. Height equals negative, refer to this one, negative 16 times second squared plus 29 t now if I were, not me, if someone was pushing a freshman into the ground, then the velocity would be negative 29, but they're throwing the freshman in the air. Notice he says straight up. So like if I were to launch something at an angle, it does change. So it's straight up, straight down, or just dropped. So the question is, when will this object, so that's asking about t.
At this time, the Health Academy is having a field trip to Hidden Valley for Health Careers Day. Please release the students at this time to the special hall. I just forwarded the letter from Mr. Kowalski. Please release all those students for the Hidden Valley for Health Careers Day to the special hall at this time. Also, since I've already interrupted, I'm just going to let you know that we do have a fall music concert here at Wyandotte tonight. So come on out and join in that. The concert begins at 7. Thank you.
All right. Well, if you watch this later, you'll get to hear all that again. So when would be time. When it hits the ground, that's when this is 0. That's when it hits the ground. So I'm going to put 0 here. Okay. Now, we learned how to find the t value. We just had x's. So we're still going to do the same thing. I don't know how I'm supposed to fit all this here, but I guess I'll go here. A is negative 16. B is 29. C is 6. I have something called a quadratic formula I could plug in. Or maybe you're doing it by graphing or by factoring. And it says t, in our case, equals negative b plus or minus square root b squared minus 4ac all over 2a. So plug in the values in. Negative 29 b 29 minus 4, a is negative 16, c 6, barely fit that in there, all over 2a, and a is negative 16. Let's see what this says. So, negative 29 plus square root 29 squared, 29 squared minus 4 times negative 16 times 6. So that's going to be 6 divided by